Hello everyone, welcome to Data 100 Discussion 9. My name is Jake, and in this week of Data 100, we will be releasing, in all future weeks actually, we will be releasing discussion walkthrough videos, and we'll be trying our best to release these videos before discussions on Thursday and Friday. And our hope is that these videos will, kind of supplement the live discussions that will still be taking place on Thursdays and Fridays. And please feel free to give us feedback on these videos as we continue to do them and continue to get better at them. Your feedback would be much appreciated. And so how this is going to work is I will be talking about question one. There are two other main sections, which will be covered in other videos by two other TAs. And okay, I think that's kind of the background. And so let's go ahead and dig right on into it. So the first main topic of this discussion is cross-validation. And we've talked a little bit about in lecture already about how the goal of cross-validation is to get an estimate of test error. And okay, before we really even dig into the process itself, I think it might be useful to talk about or list, why this process might even be worth doing. Okay, so question one says, we'll kind of cover this part of question one first. We'll talk about why cross-validation is even useful. Why are we even interested in doing it? And so as I think Joey talked a little bit about in lecture, one, or maybe the most important goal of cross-validation is to get an estimate of our test error, right? At a high level, what we want to do is we want to choose a model and train a model that performs well on data that it hasn't seen. And so our goal is to, essentially that means our goal is to get some kind of low error on the test data set. And as we've talked about, we never train our model on the test data set. That's a big mistake. Typically, we have our test data and we just stick it to the side and we don't touch it until we have a model we're happy with. And so before we even touch the test data set, we want to make sure that our model will be performing well on the test data. And so probably the most important goal of cross-validation is to get an estimate of our test error, and I guess kind of going along with that, find a model that minimizes test error as much as possible, right? We want our model to generalize as well as possible to data that it hasn't seen, and what that means is finding a model that gets low test error. So that's kind of goal one of cross-validation. And as another goal, I know we've talked about, or I think, what's today, Wednesday? Yesterday in lecture, Joey talked about regularization. And so one thing that regularization will introduce is something called hyperparameters. And these hyperparameters are generally, we'll say, parameters. So these hyperparameters, we don't really know what they should be. They're variables that we have to select. And so a priori, and by a priori I mean, kind of beforehand or in theory, we can't decide what these hyperparameters should be. We have to empirically decide what they are. And let's see, cross-validation and so really, instead of saying regularization here, I should say the goal of cross-validation is to tune our hyperparameters. And when I say tuning hyperparameters or hyperparameter tuning, what I mean is, we might pick a random value for a hyperparameter, and then we're going to adjust that parameter as we figure out which value might be best. And so this is another very important goal of cross-validation. And going back to regularization, so in regularization, if you haven't seen the lecture yet, this will introduce with regularization, we introduce this parameter lambda. And in the lecture, you'll see this kind of in a more mathy form. And really what the goal is with cross-validation is to choose an appropriate value of lambda when we're training our model. And so these are really the two most important goals of cross-validation, why you even perform it. Definitely do your best to keep these things in mind as we move forward and continue to make more models. And so having said these two things, what I'd like to do now is go ahead and describe the k-fold cross-validation procedure, which is this first part of the question here. And so here, let me go ahead and insert a shape. So let's say, so we have this shape here, and we'll say this shape is all of our data, right? So this is all of the examples or samples that we collect or get from some CSV file online. This rectangle will represent all of our data. And we've talked a little bit about the train test split in class. And so typically once we have all this data, we're going to, we'll say take a section of it. We'll say this bottom section here. And we call this our test data. And once we do this split, we've split our data, we split all of this data into this test data section and this training data section, right? So we've taken all of our data and split it into these two components. And as I was saying earlier, our goal is to create a model that generalizes well to this test data, right? And so here, let me just go ahead and make another little shape. So let's just go ahead and say, imagine this kind of rectangle here and this rectangle here are the same test data. Okay, so here, let me go ahead and say, this is our test data. And I will go ahead and erase this. And so effectively, we have our training data in this block and our test data in this block. And so, as I was saying earlier, we're going to take this test data and we're just going to set it aside. So I'm just going to stick it down here, right? And so now that we have all of this training data, we want to use this training data to create a model that generalizes well to this test data or gets a low test error. For example, root mean square error or something like that. And so cross-validation is going to enable us to do exactly that. And specifically, here, let me go ahead and say, we're going to describe the k-fold cross-validation procedure. Okay, so first, we perform our train test split. And that's what we've done here. We've split our data into training data and into test data. Okay, great. And now, what we're going to do is, instead of doing, essentially the idea is we do another train test split. But instead of calling it the train test split again, we'll call it the train validation split, or sometimes just the validation split. Okay, and so what this is going to mean is we're going to take this training data here. I'll just draw this little arrow here. So we're going to take our training data and we're going to split it into what's called k-folds. Train validation split into k-folds. Okay, and so we'll say, for example, let's say k equals 5. All right, I'm going to go ahead and move this box up here, by the way. And so what this means is we're going to create 5 kind of copies. You can almost think of 5 copies of our training data. So we're going to have one copy here. We're going to have, let's do another one. And the reason I say 5 is because 5 is a pretty standard number to use in cross-validation. Sometimes we'll use 10. Really, the number isn't super important, but 5 and 10 are common choices. Let me draw one more here. Okay. So I'm sorry these aren't exactly the same size. I'm getting used to OneNote and all this online stuff, but imagine these are all kind of copies of this training data, right? And so the idea with cross-validation is, maybe I'll pick red this time. Oh, I don't want red there. I'll pick red now. Okay. The idea with cross-validation is, once we've said we've made these 5 copies, we're going to create what's called the validation set here. And so we've taken in this first copy, and we've decided that we're going to make this little section of the data the validation set, right? And essentially what that means is that this becomes training set 1, right? This block here becomes our first training set. And so how the cross-validation procedure works is, okay, we originally have our training data. We've decided we want to do 5 splits of the training data. And so we have our first split here, and we're gonna call this part, this little bottom section here, our validation set. This is our first validation set. So validation set 1, right? And so the idea is, what we're going to do is we're going to train our model on this upper part here. We're going to train, for example, ordinary least squares regression. We're going to train it on this part of, we're going to train it on training set 1, and then we're going to evaluate or make predictions on this validation set 1. So in this way, you can think this validation set is really analogous exactly to this test data, right? So we're only training our model in this upper section, and so we can test it on this bottom section. And so typically what we'll do if you're looking for maybe some pseudo code is we'll say for each split, we'll say train model. For each training model, we'll say train model on training set I, and then calculate validation accuracy, or validation, we'll say RMSE, since I know we've used RMSE a lot, we'll say calculate the validation RMSE on validation set I. For each, I'll say I in I, for I, okay, maybe I should say for each K in 1, yeah, this makes better sense. Okay, so we'll say for each, for K in 1 through K, we're going to train model on training set K and calculate the validation RMSE, or it can be any error metric on validation set K. Then we'll say append validation RMSE to some list, right? And so basically what that means is we're going to append our validation set error to some, you can think of just like a Python list, right? And then we're going to loop through again, and we're going to consider our second fold. And we'll say fold 2, maybe it looks like this. Okay, so this is going to be our second validation set. And the idea here is that we take our training set, and here training set 2 also will include also training set 2. Right, so we're going to train a model on this section of the data and this section of the data, and then evaluate its performance on this other set of the data, right? So it's really important to understand that as we go through this procedure, we're selecting different folds. This is why it's called k-fold cross-validation here. We have, this is like the first fold of the validation set. And here we're choosing a different section of the data as our test set. This is so we avoid evaluating our model on the same data over and over again, which would not be very useful. And so essentially the idea is we're going to repeat this. So just go ahead and draw this again. Here we're going to have our training set 3. Okay, also training set 3. Right, and here in the middle, as I'm sure you all can guess, we have our third validation set. Oh, misspelled training here, okay. And since I said k equals 5, we would have our, this would be validation set 4. I'll just draw that like that. And then here, we would have our validation set 5. And this would be the training error here. This area is the training set, just like this area is the training set. I kind of don't want to type this out again, right? But I think you all get the idea. And so, kind of to recap, the idea is when we establish what k is, well, typically k equals 5, right? We're going to split our training data into 5 different folds, which I've created here with these rectangles. And for each fold, we're going to take some proportion of the training data. We'll say, this is like this area is like represents 1/5 of all of the training data because we've set k equal to 5. We're going to take, this bottom fifth of the training data and call it our validation error. And we're going to evaluate our model on everything else. We'll say on training set 1. And then we're going to, once we train our model, we're going to calculate the validation RMSE on this validation set. And we'll, say we'll append it to some list, right? And we're going to do a similar thing for the next fold. We've made this fifth our second validation set. We're going to train our model again on this training part of the data and this training part of the data at the same time, and evaluate it on this validation set, and append it to some list. And we're going to repeat that 3 more times. Okay, and the whole idea is that since we're not training our model on these validation sets, these validation errors represent test error, right? Remember, we want to get some kind of estimate of our test error using, whatever model, for example, ordinary least squares. And so the idea is once we have our 5 validation errors, go ahead and move this up. Once we have our 5 validation errors, typically what we do is we average all k of our validation errors. And this estimate, or this average, is our estimate of the test error. And so this essentially, this whole procedure here is how we're going to estimate this test error. And you can imagine, you could run this procedure for a bunch of different models. We'll talk about different kinds of models later in the semester. For example, decision trees or a random forest or something like that. And you can do this kind of cross-validation procedure and compare different models to see which one will performs better to see which one gets the lowest validation error. Because the idea is that whichever model might do best on the validation set will do best on the test data. Okay, so this is kind of the procedure for getting an estimate of the test error. And I talked a little bit about this hyperparameter tuning thing, and I guess to give a quick overview of what that looks like, let's go ahead and talk a little bit about that. This will become, I won't say too much about this because We've just barely started talking about this, but the idea is, we'll say for hyperparameter in, we'll say, some range of hyperparameters. We'll say some range of potential hyperparameters, right? We're going to run our model on, I guess we should say, run k-fold cross-validation with model trained using hyperparameter, right? So the idea here is, and this will make more sense as we do regularization more. The idea is essentially, we have this potential range of hyperparameters that we think could make sense for a model. And so generally this will be like a list or something, and we're gonna loop through this list. We'll say for each hyperparameter, we're going to run this cross-validation process with our model trained using this hyperparameter. And so essentially what this means is that for each hyperparameter, we're going to have some estimate of the test error or some validation error. And then we'll eventually choose hyperparameter that yields lowest k-fold cross-validation error. And so this is kind of the idea with hyperparameter tuning. You'll see this more as time goes on throughout the class. And so yeah, this cross-validation procedure, really the main goal is to get this estimate of our test error and to adjust hyperparameters, at least as far as this class goes. And so I think this covers question 1. Please leave any questions about this. Feel free to leave any questions on Piazza about this if this doesn't make sense. Okay, and then there's one more question we'll talk about with cross-validation. And this question is, give some limitations of cross-validation. And as far as this question goes, cross-validation is generally a very good procedure and useful procedure to use. It's very general. It's, a bunch of people in machine learning and data science will use cross-validation all the time. But it does have some limitations, and that's kind of what this question is getting at. And so one limitation that comes to mind is that it's computationally intensive. And the reason this is because, say we have some kind of crazy complicated model that takes a long time to train, right? Then in cross-validation, we would have to train that model k times, right? So say for a complicated model, and by this I really mean a model that takes a long time to train, we have to train this model k different times. And so you can imagine if k, if you're running like five-fold cross-validation or 10-fold, you'd have to train your model 5 different times or 10 different times, and that can take up a lot of time and be hard on your computer or machine or whatever hardware you're using. And so this is kind of the main, or kind of the most maybe most obvious limitation of cross-validation. And we'll go ahead and talk about maybe one or two more here. Another one that kind of comes to mind is that if our data is indexed by time, or maybe even some kind of like spatial properties. And basically what I mean by this is, say we have some kind of data collected over time, right? We don't necessarily, for example, if we have some data collected over time, we'll say, this top row corresponds to day 1, then we go to day 2, then we go to day 3, day 4, all the way up through day n, it doesn't really make sense to just, for example, take this split here, because then we're destroying the structure of the temporal structure of the data, right? So the idea is if we have data indexed by time, the ordering of the data matters. And so performing these splits like this doesn't really make sense. And so we don't really cover this in this class, but you can look up, I know there's some classes at Cal about time series, and this problem is important to resolve. And there's some, you could even Google like time series cross-validation if you were more curious about this. But yeah, the idea is if the data has some special structure, whether that has to do with time or space, or if it's just special in any way, the way the data is organized is special, you have to be careful and really determine if performing splits like this really makes a lot of sense. And so that's kind of another limitation of cross-validation, and something that we should always keep in mind as data scientists. And I think, let's see, and I think that pretty much covers this first section of discussion 9. So this was all about cross-validation. Hopefully this diagram was somewhat useful. You'll get some practice with this in lecture and lab, and as you continue to make models throughout this semester. Definitely very useful. But yeah, if you have any questions about this, question number 1 here, or question number 2, limitations, things like that, please feel free to leave any questions for me or for the other TAs on Piazza, and we'll be happy to answer those questions. All right, hopefully this was useful. This was kind of my first time going through it, so thank you all for bearing with me. Hope this was useful, and yeah, feel free to leave any questions, and talk to you guys later. Bye.